Hello and welcome to this video where we'll go into Streamlit and creating the front end and the dashboard. And before we go in there, we need to understand the data set, right? So we will do some exploratory data analysis first. Without further ado, we go into Visual Studio Code. So here I'm in VS Code and I will go into the terminal. First, I can say what I've done. I've created this Jupyter Notebook file. I have this data, utbildning.lan.xl, so it's an Excel file. I can go into this one and we see there's a preview. And in order to do this, you need to have an extension called Excel Viewer. So this is the setup for today's lecture. And before we go into, as we said before we go into Streamlit, we need to understand the data set. That's why we have EDA, Exploratory Data Analysis. However, first we need to do like this, UV, VNV, to create our virtual environment. So if you already have this, you don't need to do this, but you do need to activate it. So bin activate like this. And then I will need to install some packages with UV, pip install IPyKernel in order for me to use Jupyter Notebook. I need pandas to use pandas, and in math.lib in order to plot. I need Streamlit, and I need OpenPyXL in order to run Excel, in order to import Excel files in pandas. So let's do like that. Yes, it has finished installed. Perfect. So we go into my exploratory data analysis, and basically here I just pick the virtual environment. So if you don't have this directly, you have something called Python environments. You click on that one, you will have this .vnv that you can select. So I select this one, I create a new code here, and basically I will start import pandas as pd, and df region equals to pd.read excel. I will go out up to the parent and find data, and into utbildning.lan.xlsx and df region. When I run this one, what happens? First time it takes a little while. Okay, here, and we see that, okay, it worked. Yrkeshögskola means higher vocational education. It's a special educational form in Sweden. YH is the abbreviation. So here we see that the data starts in row 5. So basically, and also if we scroll down a little bit, we see that the data ends 6. There's 6 rows in the end that should be removed, right? So basically we do like this. We do skip rows equals to 5, and we do skip footer equals 6. And I'll run this one, and we see that all the top rows disappeared and all the ending rows disappeared as well. And now this is our data. So df region, we see that we have this data. We can do df.info. And it's not called df, it's called df region, and we see that, okay, 21, a lot of non-null, everything is non-null, perfect. However, we have some data types that are objects, some that are int. How come not all of them are int? Well, scroll up a little bit and we see Gotland, for example, has a lot of missing values, right? The missing value, they use dash instead of nan, right? However, we can replace it then. So let's do like this. df region.replace. We want to replace this with 0 because the missing value is basically, or the dash means like, there's 0 starts, right? Because this data represents number of starting education in each region. So here, and also there's some future warning here. So we basically take this and set it. Okay, we set this one and run it, and the warning disappears. So df region replace with 0 here. We we reassign it to the df region, and we take and check the head here. So perfect, now we have zeros here instead of dash. So here I will do another thing. I will do df region dot set index as lan and call it the df region. And I will also do like this. I will do index.name equals year, and I'll explain why. Well, first we set it to lan so that this is the index, and then I changed it to year. So the reason why I do this is because I want to transpose the data. I want it to be flipped. I want the years in x-axis in the rows, and I want the regions in the columns. And because when I'm doing this, it's easier for me to do plots later on. So I want to do def region dot transpose dot. When I do transpose, it looks like this, right? So now all the years are in the rows, and all the regions are in the columns. So we do like this, dot to CSV, and so this is the clean data. I clean the data, cleaned region.csv. So then we get another file here, exported the CSV file with the clean data. And with this clean data, well, then I can read it in. So here, read in clean data. So let's do that. df region equals pd.read CSV data cleaned region.csv, and we do index call equals 0, or I can show you why. Because when I do this, what happens? df region, yeah, I get it like this. This is unnamed, so I will just do index call equals 0. So this one becomes the index. So this column becomes the index. So now we have the years as index. However, the year are in int, and then we can do like this. We can parse the dates so that it and use the 0th column. So this one will become daytime. And when they are daytime, they add the month and year as well. And in order for us to fix that, because we don't have the month and year, we can do like this. Dot index equals to df region dot index dot year. So df region dot head. So basically these are now daytime, and if they are daytime, you can do one thing I wanted to have when it's daytime is that when I'm plotting it later on, it won't be crowded in the x-axis. Instead, it will help me parse so that it will give me spaces in between. And also, I can use this for slicing. So, for example, this is possible now. .loc from 2000 say 10 to 2014. This is possible. So I will get all the data between 2010 and 2014. So then you can use the you can slice using dates, right? And that is quite powerful. And also one more thing, before we had a lot of values that were object, right? Data types, because we didn't change the data and we didn't change the types. However, when we look at the region.info now, you will be a little bit surprised, maybe. All of them are int, and this is because we remember that we replaced the dash with zeros, right? because we didn't have anything there and we didn't have any education started. So when we are exporting it as a CSV file, you can look into the CSV file. You see that it's just the values here. And then when we read it again, the pandas will infer that this type is an integer, right? So this is a neat trick to do in order to do a fast type conversion. So when I have this clean data now, I can do like this. I can start plotting. So import matplotlib.pyplot as plt big comma x equals plt.subplots 1 x.plot df region Västra Götaland. As this is where I'm from, so I want to plot this one, and I want to have the option of so points with dash in between for the values between, and color equals black. We use black. X.set title number of education started in VGR. This is Västra Götalandsregionen. So, and we get this plot, and we see that this x-axis is not crammed. Perfect, and this is like some initial exploratory data analysis. Okay, so it's time to start in Streamlit. So in Streamlit, I will create a Python file called dashboard.py, and I will start with import. So importing Streamlit as st. I want to import pandas as pd, and also I want to have the path lib. I will explain why. So I need to have the path because working with path in Python scripts and in Jupyter notebooks are different. So in Jupyter Notebook, it's very convenient that when you are writing paths, you can use like this, relative to where you are right now. So where this Jupyter Notebook file is in. However, in Python script, when you run the path, you are actually, it's looking on where you are in the terminal if you're running from Visual Studio Code. And in order to solve this, we have a great package called pathlib, and from this one we can actually get relative paths from this particular file, from this particular script file with a trick. So I'll show you how to do that. So we start with the paths here. So print. So if I get like this, let's say I want to have, I can start with print path of Thunder file. When I run this one, we can see that I get this, which is the absolute path to this particular script. However, if I want to go into the data path, I will do .parent, and if I run this one, you will see that, okay, we're in Streamlit intro, right? Which is this folder. So if I want to go into the data path, I do parents of 1, then I travel back 2 steps because it starts counting from 0. So now I'm in full stack data demos, which is the root folder. And then I can do concatenation. So slash in pathlib objects are, in the path objects are concatenation of the paths. So then I want to concatenate with the data folder. So if I run this one, you see that we have the absolute path to the data. So in this way, we work with relative paths relative to where this script is. So here, I'll save this one. I'll call it data path equals to this. And I will make a function to read the data. So def read data. So then we do df equals pd dot read CSV, right? Because from the Excel file we exported a clean CSV file using Python before. So then I go into data path slash, what is the name of this one? Cleaned UH region.csv and index poll equals 0. We want to parse dates as well, like 0, like this. And df.index equals df.index.year and return df. So if I do read data now, like this, and run this one, we see that we get the data frame printed out. So we get precisely as you had in Jupyter Notebook before. So in Python script, you have to know how to work with paths and path libs in order to control it. Otherwise, it will be very difficult. So now we have the read data, and basically I also want to have a layout. So layout, and the layout we can start with df equals read data. So here we have the data which we'll be using to get it into our web app. So we do like this. st.markdown hashtag UH dashboard. And then we can do st.dataframe df. And I will also run like this. If dunder name equals dunder main, then I will run this layout function. What this means is that whenever I'm importing this script from other scripts or Jupyter Notebook, the things under if dunder name equals dunder main won't run. This will only run whenever I run this script from this file. So this is a very common trick in order for you to be able to run this as a standalone script. Otherwise, when you're, for example, if you didn't have this one and you had layout here and you're importing it from other script, then this layout will be ran as well. So that is the explanation for that. So if I run this one, what will happen? Okay, we will get some warning, and it says like this. Warning, to view this Streamlit app on a browser, run it with the following command. Streamlit run, and you have to find this file. Okay, so you can actually do this in the terminal. So you can go into the terminal and find this file and do Streamlit run after you have activated the virtual environment. However, I will do it like this instead. I will create another script called run dashboard.py. And I will give you this script here. So in order to run terminal commands in Python, you need something called subprocesses, and we will also need a pathlib. From pathlib import path. So if dunder name equals to dunder main, then I want to run dashboard. I want to find out the dashboard path. This is basically path of this current file, then the file, this current file's parent, which is Streamlit intro, right? Parent. And then I concatenate with the name of my dashboard, dashboard.py. And then I do subprocess.run, and I run. Remember that I need to have this command streamlit run, right? So streamlit run. And I run the dashboard path. And I also need to have shell equals true. So when I run this now, I will run this. I will run the dashboard. So basically, whenever you want to run your dashboard, you go into the script and you press run. Okay, and with this then, let me show you how it looks like. I will go into Brave, my browser, and you see that okay, Yho dashboard. This is what I wrote in the Markdown, and this is the data frame that we are showing. Okay, so I will do it like this so that you can see both the browser and the code. And I will remove this one. I will go into dashboard. So let's see. Let's continue building our dashboard. Let's continue building our front end. So basically, we have one problem here, that Streamlit, it interprets these dates as thousands, and that is kind of boring. That is not what we want. So we want to control it, right? So here we have the data, and we need to do something called df reset equals to df.reset index names equals to year, and then we need to style it and format it to be year. It should be formatted as lambda x f of x. And what does this mean? Well, this is a neat trick which gives us so we format it so that it removes so that it basically returns x without the comma. So that is what it means. So df reset. Let me see how it looks like, and I will type and do always rerun here, and we see that it has disappeared. Good, because I don't want Streamlit to control my design. I want to control it myself. So we have here, so with the Streamlit Markdown, we can write the Markdown code, and with one hashtag we get the h1, so that is the largest headline, and 2 hashtags we get h2, 3 hashtags we get h3, etc. That is the hierarchy of the headers. Yes. So let's do like this. So we can do st.markdown, and we can write this data shows number of started educations per region and per year. Save this one, and we can see that it comes up here. We can also do st.markdown and do 2 hashtags, and we have the raw data here. So here we have the raw data, and let me do it like this. st.markdown. We can check the trends per region. Trends per region. And we can do like region equals to st.select box. This is interesting. Choose a region, and what we need to give as selections is basically all the columns. So df.columns. df.columns like this. So if we look into the regions now, you see that here are all the columns that we can pick from. And whenever we're picking one of the columns, it's actually returned to this region variable. So basically, if I print region, you can see what happens. So we see Gävleborg, right? If I pick Jönköping, then we have Jönköping. Dalarna, we have Dalarna. Ah, cool. So we have this string returned back to us based on what the user are picking. Okay, so the user is picking a region, right? So then we can use this region to filter our data frame. So that is quite cool. So let's do like this. We want to have some trend, we want to have some statistics on a specific region. So we can do like this, region stats equal to df region. So we pick out the particular region from our data frame, and we want to do .describe, and we can see what this gives. So if I print region stats, let's say this one, we can see that, okay, for undescribed we need to have parenthesis as a method. So here for Dalarna, for example, we have here count, we have mean, we have standard deviation, mean, etc. Right? So then we can pick out the values that we want. So for example, I can pick out region stats of mean, and we can see we get the minimum value, max, and we get the maximum values. Great. Okay, so then I can do like this. I can create several columns and I can show this. So I could do like this. Cols equals to st.columns. I want to have 4 columns. And then I can do like with col, cols of 0 for example, or 0. Then so what I do is I divide my screen into 4 columns, and then I can put in different values in each of the columns. So for with cols 0 is the 0th column, I can put in a metric, st.metric. I can basically put in label equals to min, and I can do value equals to region stats of min. What will happen? Well, we see the minimum is 14, and then I could copy this one, right? And I can do, for example, 1. Instead of min, I can do max, and I can do max here. And we see that we get min, max, and we can continue to get more descriptive statistics. However, it's quite boring to copy the code. We should keep it dry, right? Don't repeat yourself. So I will erase this one, and I will put this into a for loop. So for col, stat in zip cols, stats, labels. I want to have label as well. Label. And then I will, because I'm looping through all the calls, for each call, I will put in the label here, and I will put in the region stats of instead of min, let's see, it's the stat, right? So here we need to define stats and labels. So stats equals to mean, median, and we have what else? We have max, and for example, or it's actually not called median, it's called 50% in pandas describe. Labels, I will call it mean, median, and max. So then we see when I loop this through, we get here mean, median, max. So I change another one. We go into Gotland and we see here other values. Jönköping, we have other values here. Stockholm, yeah, even larger. Yes, and so for example, this is what you want to show. You could show more statistics if you wanted. And also we may not want to have, we want to round this, right? So we could do f-string here. Let me do like this. F-string colon dot 0f. Like this, and we don't have, we remove, we cut off the last decimal here, so we don't have decimal because these are integers. Yeah. So let's do a plot here, and we can actually do plot with Matplotlib. We can do plot with Streamlit directly. They have some charts, but we can also use Plotly to get interactive charts. So let's do with Plotly. And for that, we need to import Plotly. So import plotly.express as px. And then in order to do that, we need to install. So uv pip install Plotly. It's quite a large package, but it installed quite quickly. So then we can use Plotly graph here. So fig equals px.line, data frame equals df, x equals df.index, y equals df region, because the region is the one that we have picked, right? Based on, like we have here, the region is from the select box, so from what user have picked. So we have this, we can continue doing title equals to f-string started educations in region, and during 2007 to 2023, like this. Also we can have, yeah, we can do this fast, and we do st.plotly chart of fig. So, and here you can see the Plotly chart. Perfect. So if I change this one, Gotland, then we have another chart. Uppsala, we have another chart, and you see that it's interactive, it's Plotly chart. So we can change some more things here to make it nicer. Labels, we have index. This one I will put as year. Region, I'll put it as started educations. So save this one, and we can see that this the x and y label changed. We can update this. Fig.update phrases. Line equals dict of width equals 3, so I can change the properties. So here I get thicker lines, and I can continue here. Fig.update layout, x-axis equals dict show, grid equals to false. So I remove the grids. Let me see why it didn't change. Show grid equals false. X-axis dict show grid equals false, and then it was the x-axis, right? And y-axis, I also want to have this dict show grid equals false. So now I removed the grid. Okay, so this is, let me see if Västra Götaland. Yeah, perfect. This was what I looked for. So now you have an interactive dashboard. Even though it's very simple, it's still interactive, and you can choose here whichever you want, and you see the graph updates itself. Yes, and thank you, and see you in the next lecture. Bye.